Hello everyone, and thank you for attending this session at the 26th International Conference on Fracture and Structural Integrity. My name is Poorya Karvan, and today I'm presenting a work on the effect of climate-induced parameters on fracture properties of semicircular coated wooden specimens under three-point bending. This work was conducted under the supervisions of Professor Razavi, Professor Berto, and Professor Bertolin at the Norwegian University of Science and Technology, NTNU, in Trondheim, Norway. So generally, wood is regarded as a common material in construction within Northern Europe. One different type of wood is a Scotch pine, a popular material in historical and contemporary buildings in Norway, as shown in the pictures of the two stave churches here. But the problem with the wood is that it is highly susceptible to the variations of climatical parameters such as relative humidity and temperature, resulting in generation of macrocrack, as you can see in the picture on the right hand side. This picture is of a naturally dried Scotch wine placed outside of the laboratory in direct exposure to the harsh environment of Trondheim, with temperature and relative humidity values vary significantly between summertime and wintertime. This damage jeopardizes the structural integrity of such buildings, and in order to prevent that, it is important to thoroughly investigate the effect of such parameters on fracture properties of wood. To do that, 10 slices of Scots pine were prepared with the diameter of 130 millimeter and thickness of 10 millimeter. One out of the 10 slices were placed at the room temperature condition with temperature around 21 degrees of Celsius and relative humidity of 30%. The remaining 9 were placed inside a climate chamber for the purpose of 3 stages of acclimatization. The first stage was for that 9 uncoated samples to stay at relative humidity of 80% for 18 days. Then the relative humidity dropped to 30% and the top and bottom surfaces were coated as follows: 3 slices with wax, 2 slices with high amount of paralloy, and 1 slice with low amount of paralloy, while the remaining 3 slices were kept uncoated in order to be compared with the 1 slice kept outside of the climate chamber. The final and third step was to keep them at 30% relative humidity for a minimum of 21 days to reach the moisture equilibrium. This a month and a half process of acclimatization results in the crack in the slice, so as you can see in this picture as a sample here. To find out the value of the K1C of these Scots pine coated and uncoated, those acclimatized and those kept outside, a 3-point bending on semicircular testing specimen was chosen. 6 specimens per slice were cut with the radius of 20 millimeter and the pre-crack of 10 millimeter. 3 in the RT direction and 3 in the TR direction. In each direction, the specimens were cut in a way that they are on the same annual growth ring to have a better reference for comparing them with each other. Then the 3-point bending test using a universal testing machine was performed with a span of 32 millimeters. The result is drawn in this picture. The sudden drop of the load shows the brittle type fracture. The maximum value was recorded, in this case 100 Newton, and used as an input for the finite element model. This finite element model was a 2D model with elements of plane strain, mostly 8 knot, some of them are 60. The placement of the boundary condition and the force is shown in the picture. Also, the magnified figure shows the density of the elements, which is higher than usual for the crack tip in order to avoid the singularity and have a better value of K1C. By performing this simulation, the result was obtained as follows. So the value of K1C on the vertical axis are drawn versus the specimen's type and coating of the sample. As you can see, there's a small note here for the horizontal axis. The first one is the standard uncoated one kept outside. The second one is standard inside the climate chamber, paralloid with high amount, paralloid with low amount, and wax. The greenish color is in the TR direction, and the orangish color is in the RT direction. The value shows a slight difference between the value of K1C in the TR and RT direction. The conclusions drawn from this experiment and this work are shown in the next slide. So by studying the impact of acclimatization and coating on fracture resistance of Scots pine, it was concluded that this acclimatization process of uncoated slices had a small effect on fracture resistance. However, it reduced the standard Scots pine fracture resistance compared to the one that was kept outside of the climate chamber. The values of K1C vary slightly in RT and TR directions. Having said that, for uncoated and coated with high amount of paralloid, fracture resistance was higher in the RT plane. However, those coated with wax and low amount of paralloid had higher values of K1C in the TR system. Overall, samples with low amount of paralloid coating had the higher fracture resistance, while those acclimatized and uncoated had the lower fracture resistance. Finally, I would like to thank the Italian group of fracture for providing this platform, specifically in this unprecedented situation that we've been going through for the last year or so. Also, the financial support of the Research Council of Norway financing the symbol project, the sustainable management of heritage buildings in a long-term perspective, is very much appreciated. The NTNU, the Department of Mechanical and Industrial Engineering, and its staff are greatly appreciated for their help for preparing the samples. At the end, I'd like to say that I wish that this conference I could attend it in person, but hope to see you all next year in a better circumstances. Stay safe and take care of yourself.